I'm Helene Kaur, and today I will talk about Kubernetes, a container orchestration platform essential in modern software engineering. Over the next 10 minutes, we will explore what Kubernetes is, why it exists, and how it relates to software engineering principles. Let's start with a problem that Kubernetes solves. Imagine managing 50 microservices across 20 servers. At 3 a.m., one server crashes. How do you detect which services failed? How do you restart them on other servers? How do you update routing and prevent cascading failures? This is a container orchestration problem. At scale, manual management becomes impossible. You need automation for deployment, scaling, failure recovery, and networking, and this is why Kubernetes was created. So, what exactly is Kubernetes or KATS? It is an open source container orchestration platform that automates deployment, scaling, and management of containerized applications. Originally developed by Google, it was donated to Cloud Native Computing Foundation in 2014. Think of it as an automated infrastructure manager. If a container crashes, Kubernetes restarts it. If a server fails, it reschedules the container to healthy servers. If traffic increases, it auto-scales your applications. Core capabilities include automated deployment, self-healing, load balancing, auto-scaling, and rolling updates. So, let me show you how we got here by tracing the evolution of application development. First, you might run a single container on a single server. That's perfectly manageable. You can start it, stop it, monitor it, easy. Then your application grows and you need multiple containers working together. Maybe you have a web server container, an API container, and a database container. You still manage this manually and with some scripts, but it's getting harder. You need to coordinate which containers starts in what order and how they find each other and what happens when one fails. Now imagine your system has grown to be truly distributed. Dozens or hundreds of containers spread across many servers with complex dependencies between them. At this scale, manual management completely breaks down. You need an army of operators working around the clock just to keep things running. You need automated orchestration. And this is the natural progression that leads to the tool like Kubernetes. It is not about adding complexity for its own sake, it's about managing the complexity that already exists in large scale distributed systems. When you reach a certain scale, automation stops being optional and becomes essential. Now, now, let's discuss about the core concepts of Kubernetes and the fundamental building block of it is pod. A pod is the smallest deployable unit in Kubernetes. Think of it as like an apartment housing one or more containers. Most commonly, you will have one container per pod like your web application. But sometimes you have helper containers like sidecars. Containers in pod share networking and storage so they can communicate easily using localhost. Importantly, pods are ephemeral, temporary, and disposable. Kubernetes creates, destroys, and recreates them as needed. This disposability enables self-healing. Now, two more essential concepts of Kubernetes, which are deployments and services. A deployment declares your desired state. You tell Kubernetes, I want 3 replicas of my app running at all times, and Kubernetes maintains that state continuously. If the pod crashes, it creates the replacement. Uh, and if you update your app, it orchestrates a rolling update. You declare what you want and not how to achieve it. That is what is Kubernetes for, and it figures out how you can achieve what you want. Services provide stable networking. Since pods are ephemeral, with changing IP addresses, services provides a fixed endpoint like a load balancer, routing traffic to any healthy pod. This enables reliable service discovery and communications. So, moving forward, Let's pause the video and think about this. You are on a call for 50 microservices uh, across 20 servers that we discussed on our very first slide. A server fails at 3 a.m. What problems you face managing this manually? Think about detection, recovery, and preventing cascading failures. I'll give you 10 seconds starting now. Okay, so let's walk through it. First, detect which services were on that failed server. Then manually restart each service on available servers, but which ones? Check resources utilization and decide. Update load balancer configuration for traffic routing. Fix service discovery, update DNS records so dependent services can relocate instances. You have to monitor for the cascading failures. And you have to do it all of these things when you are half asleep at 3 a.m. One mistake makes this worse. Kubernetes automates all of this. It detects failures within seconds, automatically reschedules pods to healthy nodes, updates services routing transparently, and maintains systems healthy continuously without any human intervention. Um, isn't that convenient? Now let's move to an example where I've shown how Kubernetes configuration look like. It's a sample YAML deployment file which says I want 3 replicas of my web application running all times using a version 1.0 of my container listening to port 8080. So you have mentioned how many replicas you want. You have mentioned the image from where what it needs to deploy, and you have mentioned the port here. Once you apply this, Kubernetes handles everything. Pulls that image from your Docker registry, creates 3 pods for you, distributes them for high availability, monitors health continuously, and replaces failures automatically. This is the declarative configuration. You describe what you want, Kubernetes figure out how and maintains that state. And now let me show you self-healing in action. Say you have 3 pods running at time 0, all healthy. 1 minute later, one pod crashes, maybe out of memory. Within 5 seconds, Kubernetes detects this failure through health checks. Within 10 seconds, it schedules a replacement on healthy server. Within 20 seconds, the new pod is running and receiving the traffic. The entire recovery automatically happens within 30 seconds. No alerts, no emergency call, no manual interventions, and Kubernetes continuously compares actual state against the desired state and corrects the discrepancies. This builds genuine resilient systems. So, why it matters for software engineers? First, because of reliability. Kubernetes handles failures gracefully, providing high availability without complex manual procedures. Less downtime for users, fewer 3 a.m. calls for you. Now, another major point is scalability. Horizontal scaling, adding more instances rather than bigger servers. Your applications grows from hundreds to millions of users without fundamental rewrites. And third, the productivity. Faster, more reliable deployments, consistent environments from deployment through production. Focus on writing code and shipping features and not on deployment procedures and infrastructure deployment. So, Kubernetes, what is the real world usage of Kubernetes? So, it's not just a concept or experiment. Rather, Kubernetes is widely adopted in production. Spotify manages their microservices with it. Airbnb uses it for data infrastructure and machine learning. And New York Times uses it for content delivery. Pinterest, Reddit, and countless other companies rely on Kubernetes. So common use cases include microservices architecture, machine learning pipelines, data processing workflows, multi-region applications, and CI/CD infrastructure. Over 5.6 million developers worldwide use Kubernetes. Isn't it fascinating? Now, another thing that we need to understand before start using Kubernetes is when to use it and when not to use it as a software developer. So you have to use it when you have to use this Kubernetes service, when you have multiple microservices needing orchestrations, when you need high availability, when traffic patterns are variable, when you are deploying to multiple environments, and when your team has a DevOps expertise to manage your Kubernetes deployments and servers. However, you can skip Kubernetes deployments if you have simple monolithic app on one server. If you are just starting a new project and wants to keep things simple, you can add complexities later point of your projects. If your team lacks DevOps experience or if complexity outweighs the benefits from whatever you are benefits getting from the Kubernetes. So remember, start simple and scale when needed. Don't over engineer. A well designed monolith on one server often beats a poorly orchestrated distributed system. So, what are the key takeaways? There are five key takeaways. First, the problem managing distributed applications at scale is complex. Second, the solution Kubernetes automates container orchestration. Third, core concepts involve pod, deployment, services, and these are the building blocks of Kubernetes. And finally, and fourth, self-healing makes systems genuinely reliable. So you do not have to wake up every morning if a server breaks down. So Kubernetes has taken care on behalf of you. And finally, know your needs, when to use Kubernetes and when to not use Kubernetes. If the complexity uh, is justified with your requirements, then definitely go ahead and use Kubernetes. But if it is making it more and more, if it is creating more and more problem for you, then maybe it's time for you to skip it. So, how is it Kubernetes embodies core software engineering principles? First, automation reduces human error and increases reliability. Then, secondly, we have declarative configuration, which infrastructure as code with version control and testing. It gives us fault tolerance with the assumption that failures will happen. And finally, separation of concerns. Developers focus on writing code rather than, and Kubernetes handles the operations. So your developers doesn't have to take care of infrastructure management and on any other uh, problems dealing with the platform. They can focus completely on writing code. Um, so, if you want to learn more about Kubernetes, Kubernetes official documentation is available on kubernetes.io and it's extremely in depth. So, if you want to learn it fully, I would recommend to go through it. And I've also attached a couple of more links, couple of more resources for you to figure out what Kubernetes is and how to make it work for your applications. Um, and that's all from my end. Thank you so much.